Please welcome Vice President, Engineering, Storage, Automation, Streaming, and Management, AWS, Bill Vass.
Hey everybody, isn't it great to be back here in person? Everybody having a good reInvent? Yes, I hope so. So we're going to do a little bit deeper dive into edge to cloud and what we're doing in that space. Adam covered a good amount of it in his presentation. Some of the stuff we're doing with digital twin and robotics and things like that, and IoT and connected cars. And Werner just talked about extending the cloud. Of course, he didn't get it all the way out. He talked about getting it into space, but our furthest edge deployment right now is the stuff we did with NASA JPL with a NASA rover. So we're on Mars today with cloud services, which is pretty exciting. But the latency is quite a hard problem there, as you can imagine, due to speed of light and things like that. So we're going to have some great presentations today from Gavin, who's going to be showing us some cool stuff with Ghost Robotics and what they're doing and creating 3D environments there. And Grace is also going to show you some things. Some of the things you might also notice in this Edge to Cloud presentation, our team also works on simulation and rendering and gaming, and Werner covered a little bit of that this morning as well. And you'll start to see this sort of integration and convergence between digital twins, simulation, gaming and movie rendering and physical modeling and high-performance computing and edge collection of data to be used in that, and point clouds and things like that. I think that'd be pretty exciting for you guys to get to take a look at. So we're talking about the challenges at the edge. The Mars rover has got quite a lot of latency there, about 20 minutes each direction. How you simplify your edge initiatives, a little bit about making the edge secure and reliable and why that's important. Amazon's been doing edge processing and large-scale distributed systems for a very, very long time, many decades, and how we take what we learn there and build it into our products, and some great customer examples today. So when we talk about the edge, if you're not sitting in an Amazon data center, then you're sitting at the edge. So that's the way we think of it. If you're not in one of the availability zones in our data center, then you're at the edge. And so it's things like connected cars. We're doing a lot of things there with ADAS and connected cars, and you saw our launch of FleetWise. You see like a 5G and things like that. The hubs for that are edge processing nodes for us as well. We've got the rugged edge, network monitoring, and then the ability to push the cloud out to the edge for very low latency processing and things like that. And of course, we also want the infrastructure to be smart. We want to get to the point of a software-defined network and a software-defined distributed system with machine learning and other things being leveraged, and the ability to run that machine learning right at the edge to filter data. And we deal with the three laws here. The law of physics, of course, we can't get faster than the speed of light. And of course, our quantum computer team is thinking about how we might be able to solve that one day with quantum networking. But today, you can't exceed the law of physics. We've got the law of economics. For example, a lot of the movies today are shot on snowballs rather, and those get shipped in because it's just too much data. It's hundreds and hundreds of terabytes being shipped in because it's too expensive to send that over satellite, or seismic data collection, or a lot of times the point cloud collection is done on snow cones and things like that, or ADAS driving collection is done there. It's just not economic to send that over the networks today. And then law of the land. There's places where you have data residency requirements, or that you have to have your data close to other systems that you're running. So if we look at the edge to cloud, and I didn't include Mars on here, but I guess you could. But if we start at the very edge, we have our microcontrollers and advanced IoT devices there on the edge that are running FreeRTOS and Greengrass, things like that. As you move closer to the cloud, in some ways, you've got networked environments like a factory floor, which you'll see with our digital twin and things like that, where a lot of IoT devices are working together. Some of our customers have 250,000 IoT devices coordinating inside a manufacturing center there. And then as you move to the network hubs, moving closer to the cloud, you've got the ability to have, with 5G, this hub and spoke architecture, where you've got our wavelength products, and you can do delivery of AWS services there. And of course, as you move to the ruggedized edge, that's, Werner mentioned that as well, where you've got our Snow products and things like that allow you to do local processing and storage there right at the edge, and then ship that in if you need to, or keep it there for long period of times. And then you have on-premise, where you can put the outpost in on-premise, and metro centers. And then finally, you get back to our POPs, which you can do both processing on, and then last, of course, definitely not least our regions, which gives you the 3 availability zones and the high availability you have out there. And what we're doing here is delivering centralized control and decentralized execution. You don't want decentralized control, because then you have decentralized or chaos, right? So you want to centralize control, you want to be able to see what's going on, manage what's going on, optimize what's going on, and you want a consistent development environment from the edge to the cloud, common set of APIs. You want consistent connectivity management, you want consistent deployment, consistent management, and consistent security from the edge to the cloud, right? And that's what we're trying to provide here as more and more we integrate these things. Eventually, the network and the system will be smart enough to distribute your load automatically across here, and that's our ultimate goal there, is you decide where the best latency is and best performance is and best amount of commute that's available to you, and put your application there, and it'll distribute it automatically. So the goal is, of course, to make it very easy to connect. We already manage many billions of devices here at AWS. I think we're streaming in something like over 40 trillion records per day into Kinesis. That's the underlying platform for a lot of this, and extending 5G and things like that, and make it easy to connect the devices, easy to deploy. So you do simple over-the-air update. And you saw, if you were at my talk yesterday, that we've now extended System Manager to also manage the OSs on IoT devices. So in one frame, you can see in a factory your Snowballs, your Outposts, your other products, and your IoT devices, and what's on the cloud, and do a single patch across all of them, and easy to deploy and push out. Of course, security for that push out is very important as well, and you want to make it very easy to manage. And security, that's really our top priority here at Amazon. We first do security before we do anything else, because if it's not a secure and available, nothing else matters. And so we have handshakes, dual key authentication, tunneled encryption, layered encryption. We use formal methods for anything that is related to security or network connectivity in the code to make sure that it's the maximum security there. So that's very, very important to us as well. And of course, we have things like Device Defender, and that protect against denial service and other things like that. And so that's really core. And all of our products at AWS, for the longest time, since 2014, we've been running a top secret compartmented cloud. So we're rated at authority to operate TS/SCI level 6+. That's life critical impact data. That is the highest security, objective security rating in the industry, bar none. PCI, HIPAA, all those things are not nearly as strong. And we run all of our products through that. And it's the same product that runs on our commercial cloud, runs on those intelligence clouds. So all these products go through this. So you can count on the default best security in the industry, meeting all the compliance regimes, but even stronger with the TS/SCI ATO level 6 on our products. And of course, region availability, we're the top in availability in the industry, and that's really important for your back end at the edge. One of the important things, we always separate our availability zones by 10 to 60 kilometers. If you ever see a provider that's got a whole bunch of buildings in one place, you should probably run away and not put your data there, because one tornado takes everything out. You want to have them separated by at least 10 kilometers. You don't want them across the street from each other. So we separate them by 10 to 60 kilometers, and we can have multiple buildings in each availability zone as well, multiple availability zones per region, and you can separate your data regionally as well. And this is how we get the 11 nines of durability for the storage back there for your management at the back end. And so, of course, we've got a tremendous amount of experience running edge environments at Amazon. We have over 250 or over 200 fulfillment centers out there, over 350 robotic drive units. We were at Midnight Madness. We launched RoboMaker there, and we did launch it originally there, but we also launched RoboRunner at this reInvent there, and we had some of the drive units on stage and things like that. But managing those 350,000 drive units everywhere, that's an experience that nobody else has out there today. And of course, hundreds of millions of Alexa devices managed out there, and Alexa-compatible devices that we can update and manage. And so we've been doing this for 2 decades. And so we take all of that experience and build it into the products that you can use for your environments. So what I'm going to do now is turn things over to Gavin to talk a little bit about what Ghost Robotics is doing with us. Gavin, why don't you take it away?
Great. Thanks, Bill. Hi, my name is Gavin Keneally. I'm the co-founder and chief product officer at Ghost Robotics. At Ghost, we developed the Vision 60 legged robot as a cross-use platform for both government and commercial applications. It's a fully sealed and ruggedized four-legged robot that has exceptional endurance of 3 hours of continuous walking with perception. You can also think of the machine as an IoT device on legs. And so when we needed to manage the software deployments for a wide array of applications on our platform, we turned to AWS IoT Greengrass. These diverse applications include perimeter security, communications including 5G, secure computing on the edge with AI and analytics, chemical, biological, radiation, and nuclear threat detection, creating a digital twin using LiDAR and other sensors, as well as extended capabilities that come from adding a manipulator arm or a UAV. When the Jacksonville Jaguars needed a digital twin of their NFL stadium to inform future expansion, renovation, and other opportunities, we partnered with Haskell Construction. Combining the LiDAR scans from both the UGV and our legged robot, we created a huge amount of data, for which we needed secure and reliable storage and analysis. So once again, we turned to AWS and Amazon S3 to get the job done. So here I'd like to show you a video of what it actually looked like to map the stadium. So the first thing is we equipped both the drone and the legged robot with a LiDAR system. This yet let us use SLAM mapping technology to create a geometrically accurate point cloud, which ended up being the digital twin. SLAM stands for simultaneous localization and mapping. The two machines have complementary capabilities. The multi-rotor can quickly get a coarse point cloud by flying through the stadium and reaching tall structures, while our Vision 60 legged robot collects very dense data by walking all throughout the interior and the stairs with its superior endurance. All this data gets stored in Amazon S3, and we were able to scan the entire 67,000-seat stadium in only one day. Thank you very much. I'd like to hand things off to Grace Reed. She's the product marketing lead at AWS Robotics. Thanks.
Hi, I'm Grace. I'm the product marketing manager for AWS Robotics. I want to thank Gavin for his time today and for being such a great partner. Today, I want to talk about robots. Robots really are the ultimate edge device. They use edge processing to sense the world around them and then react in real time. In the past 10 years, advances in machine learning, edge processing, and simulation have brought robots out of the lab and into the real world. We see our customers building and using AI-enabled robots for a variety of different use cases across industries, from healthcare to agriculture to industrial. The scale at which robots are being used creates complexity. Complexity for robot builders who want to accelerate robot development without compromising code quality, and complexity for robot builders who want to add new robots to their operations while maintaining efficiency. At AWS, we've built services to simplify and accelerate robot delivery and to make robot fleets more efficient. Developing and testing robots is time-consuming and takes a lot of iterative trials to get right. Our customers are limited by the physical space they have and the physical hardware, the robots. That's why simulation is such a powerful tool for robot development. In 2018, we launched AWS RoboMaker, so our customers could leverage the power of simulation and test their robots in 3D virtual worlds that mimic the world around them. You can do years of testing and training with simulation in just a couple of minutes. You can automate testing workflows into a CI/CD pipeline. You can validate new robotic systems in just a fraction of the time it would take you in the real world. And you can even generate synthetic data from simulated worlds that then you can use to train computer vision models. In our Amazon FCs, simulation helped reduce the time to design an entire new warehouse from over a year to just 3 months. And you're about to see some other amazing ways our customers are using simulation. They're using simulation to test new drone technology. They're using simulation to test workflows in Amazon fulfillment center and transportation centers. You can see here a simulated Amazon robot. They're also using simulation to generate synthetic data and identify errors on conveyor belts. They're using synthetic data to make sure robots can operate safely in disaster zones or even solar fields. They're using simulation to improve autonomous driving algorithms and ensure our robots are operating safely in our homes and in healthcare venues where they keep us clean and safe. But when we talk to customers, they tell us that after they deploy robots into the real world, they need help managing together seamlessly. And that's why we launched AWS IoT RoboRunner. AWS IoT RoboRunner is built on the same technology used in Amazon fulfillment centers to manage a multi-robot fleet. With RoboRunner, you can connect multiple different types of robots to a common infrastructure. Then you can build applications atop this infrastructure for robot orchestration use cases, like robot collaboration and shared space management. The best part is robot operators can use these applications to see what's going on in their operations in real time and make decisions quickly to fix issues or optimize different workflows. But robots are just one part of industrial automation. When we talk to our customers, they need to understand the full value of what's going on in their operations. One way our customers are doing that is by building digital twins. Digital twins are a living representation of a physical system that is dynamically updated and used to drive business outcomes. We're already helping our customers build and use digital twins. One of our customers, Coca-Cola İçecek, or CCI, operates at a massive scale. They are the world's 6th largest bottler of Coke products. CCI wanted to use a digital twin for greater visibility into their cleaning processes. They used AWS IoT services like Greengrass and SiteWise to capture the data and then build it into their digital twin. And they achieved some amazing results. They were able to identify 20 points of optimization, reduce water consumption by 20%, and were able to add 34 days of production to their schedule. But as we were talking to customers, we learned there's room to make it easier to build and leverage digital twins. Customers tell us they have 3 challenges building digital twins. One is capturing the data, like I mentioned with CCI. The second problem is building that 3D model that accurately represents their operations. And the third problem they have is making it easy for their operators to use digital twins so they can understand what's going on and make changes to fix problems. And that's why we launched AWS IoT TwinMaker, which makes it faster and easier to create digital twins of real-world systems like buildings, production lines, and factories. With digital twins, our customers can access data no matter where it lives in immersive 3D views. And these 3D views are really cool to look at, but they're a lot more than that. They provide context into all the other components in the operations. So when something goes wrong, you know what's contributing to that and what the impact will be. And one of the coolest things about TwinMaker is the ability to double-click on the 3D view and see an actual live feed of what's going on in the operation. This is something that differentiates this product from other offerings out there and will be so powerful for operators to actually know what's going on and resolve issues faster. Let me show you what that looks like in action.
Digital transformation is producing a wealth of benefits for companies, but it's also creating vast troves of operational data. In order to stay competitive, we need to create a centralized view of silos of data. This is where digital twins step in, a working, scalable, living digital representation of your facility as an operating ecosystem, visualized in 3D. But until now, doing this was complicated and out of the reach of many customers. Introducing AWS IoT TwinMaker, a service built to bring digital twins within reach for everyone. With AWS IoT TwinMaker, we give you the power to easily bring together sensors, data, equipment, production lines, and live video into a consolidated digital version of your operations. By importing your existing 3D models directly into the service, you can then create immersive 3D visualizations of your real-world environment, showing real-time data, video, and insights, enabling your operators to make more informed decisions more quickly. Start building today and see what AWS IoT TwinMaker can bring to light for your business.
We are so excited about how we can help our customers get the most value out of their edge devices, from robots to sensors to your entire industrial operation. Now I'm going to pass it back to Bill, who's going to tell you more about our customers.
Thanks, Grace. That was great. It's really exciting to see the situational awareness you get, as opposed to just getting a dashboard where, oh, I have an alarm. You can actually see it's Mike eating the cookie dough in your cookie factory, right? And just dive into it and see what's really happening in the real world there. And of course, I really want to talk a little bit about our partner Siemens. It's great to have them as a launch partner for our digital twin product. Siemens has been an industrial partner with AWS for over 8 years, and it's great to have someone who's an expert in industrial settings to work with us together on things like Volkswagen DPP and other things like that, and the industrial platforms there. So we continue to expand our relationship with Siemens and other industrial partners there who are experts in the cloud, experts in industrial, and take our expertise in the cloud and combine it with them. And you know, as I mentioned before, too, you're also seeing this convergence again of things like game engines and other rendering engines. Today, as a matter of fact, we launched with the Linux Foundation the O3DE engine, the next release of it today, that can be used for building things like this. So it's pretty exciting. That's kind of the things that are happening under the cover. That was a Grafana frame delivering all the digital twin information with a 3D rendering embedded in it, and Kinesis Video delivering the video components for that, so you can turn your video cameras into IoT sensors as well, which is pretty exciting. So, you know, our goal is also to extend into automobiles and make it easier to connect cars, because cars they are the software-defined network of the future in some ways. Cars are becoming more and more software-defined, especially as they become electrified. And so one of our key partners here is BlackBerry. So we announced a deal with them last reInvent, and I'm just going to give you a quick update on sort of where we are with that and what's happened there. Of course, BlackBerry is on over 195 million vehicles. 10 out of the top 10 manufacturers use them. They make an extremely secure level 6 certified operating system that runs on the vehicle, and we're able to bring our machine learning into their platform, our web services into their platform, our connectivity into their platform, so that it provides an underlying capability for auto manufacturers that are using it. And here are just some great examples of what we've already accomplished in building with a few automakers and testing out what's possible there. These sort of next generation edge software capabilities, being able to combine sensors in vehicle, run machine learning in vehicle, connect back to our IoT, and, you know, do predictive of battery use and motor situations and things like that, based on how the user's interacting with the vehicle as well. And that's one of the examples there of one of the screens that it produced. So we have a great deal going on there in connected vehicle. But in addition to that, there's a lot more happening in the connected car, just at the above where QNX operates. There's all sorts of sensors and data being collected there. Something like 2 terabytes of data collected every hour. Now, if you take a look at like some of our other customers, they've got snow cones and snowballs in the trunk of their test vehicles, and they're aggregating and processing that data in real time and then bringing it back in the cloud and doing some of the simulations you saw that Grace showed you there with the ADAS simulation that was going on there at the back end, using that data that's collected out in the field. But there's also going to be continuous increased processing in the car as the car becomes software defined, and we want to make it really easy to do web services in the car, connect to the car, and enable to get that data back to the cloud securely for our automotive manufacturers out there. And so we released, announced at Adam's keynote, FleetWise. So FleetWise works across any vehicle, no matter what operating system capability it's got in place. It's a standard vehicle data system. It really reduces the cost of networking because it does intelligent filtering. So you don't need to send everything back. It's using machine learning to that. And in fact, if you have a fleet of common vehicles and they're sending back a common view, it can aggregate across those vehicles and only send one copy instead of 3 or 4 copies of the same data. And it allows you to detect problems quickly, and it builds a data lake for you in the back end. So you can see not only a digital twin of the vehicle, individual vehicle, but you can see the status of your entire fleet. And of course, it works with any vehicle, right? And that's why we call it FleetWise. So any fleet of vehicles we manage with this. And for a lot of our automotive manufacturers, the security that we provide at that high level and the ability to do over-the-air update for them is really critical here. So we're very excited about FleetWise and what we're seeing with manufacturers there today. And of course, you work in these hybrid environments as well, as we mentioned before, and as Werner talked about what's going on out there. And you see like NASDAQ moving to AWS, very exciting to have the exchange running on AWS as well. And this is where our Outpost products come into play. The ability to push your low latency processing into your manufacturing center, into the 5G hub, or into your retail site. And of course, we recently just GA'd the 1 and 2U outposts in addition to the full rack there. And you can use these as aggregation points. You can run Greengrass on it, all these different products running there locally as well. And so that also, we're working to push the networking to the edge as well. Okay, with our POPs and things like that, and we're doing a lot of work with those with Epic to deliver gaming there right at the edge. And so just amazing volumes there on Fortnite running on AWS and be able to push that out. Over 200 million plus players and about 8.3 million concurrent players running across 12 AWS data centers, 24 availability zones. There's an amazing amount of edge processing happening there as well. So as we work to work with our telco providers to push these edge hubs out there, we have this idea of pushing AWS and AWS services to multi-tenant edge hubs with our Wavelength products as well. And so Werner mentioned a little bit about that, and we talked a little bit about the work we're doing today with Dish. So Dish has got a fully software-defined, scalable edge environment that runs the entire network switching system and everything on the outposts in the 5G. Core that they're delivering out there. So that's a very exciting extension of the AWS services to the edge and the ability to have a software-defined switching system there. And of course, we mentioned in Adam's keynote this private 5G network. And of course, we're focused on underserved communities, but we're also focused on farmers' fields and mines and other things like that, and also manufacturing centers. So a lot of people say, well, why do I need a local 5G? Why do I need a private 5G? And I'll give you a great example we ran into at our Midnight Madness. We had a couple of the robots on stage, and they're running on Wi-Fi. If one of them moved when the other moved, the Wi-Fi started to conflict. And we ended up with a denial of service issue on the Wi-Fi. Well, the private 5G in a manufacturing center can be segmented out by device, and you have control spectrum on it. And so these are going to be very popular in manufacturing centers and things like that. And of course, we deploy this on our snowballs. In fact, that one picture in the lower side there is a robot being controlled over the first 5G network in the Middle East that's running on that snowball, controlled by that antenna up there that's on the air conditioning duct. And you have the ability to put this in mobile locations and field locations kind of all over the world. So it's pretty exciting to see how customers are going to use this, especially in manufacturing settings, because you can drop these snowballs in and plug them in, turn them on. You have an instant 5G network that you can set up and run. So very excited, or in a farmer's field, or in a mine, or on a ship, or anywhere you have to be, and then take full advantage of the capabilities of 5G as opposed to just running Wi-Fi. So that's pretty exciting. And that's what this private 5G is all about. Just in days, you can get it up and running. We can ship it to you with a secure device, and you can scale it by adding more snowballs. It also runs on snow cones, so for smaller deployments, you can deploy it out on a snow cone. And of course, the snowball continues to be our rugged edge and our rugged edge development. a platform as well where you can both compute and operate on the edge. And also ship data if you need to. So I think that's pretty important. So we need to play the video for that. There we go.
So my name is Adam Chugg. I'm a Principal Solutions Architect at Amazon Web Services. Standing next to me here is a AWS Snowball. This is our edge compute device. These devices can store several terabytes. They also have a basic computer inside of them, which allows you to run your own programs. That allows us to take real-time data from the cars. So we're able to take things like shock potentiometers, steering angle sensors, things like that, grab that data in real time, run it through this device and be able to give back data that's being able to be used by the teams. From there, once we're all done, these things can be boxed up, packed up, shipped back home. They're ruggedized, it's waterproof, and are able to make the transit back to the home base.
Hello, CJ Moses here, Deputy CISO for AWS and also the driver of the 58 AMG DXDT AWS and CrowdStrike race car. This device here is actually something that we use here at the track in order to improve our performance on track. And as part of that, we're able to do advanced processing on the Snowball device that is then near real time pushed into the cloud. When we plug into the car, we can get as many as 1,200 channels of data. Using all of that data and processing it through the Snowball devices allows us to get faster on track, both through improvements for the driver, knowing where we can actually improve on the track, but also using the data about the car so that we can improve the suspension or otherwise based upon all those channels of data. The same type of technology that we're using here at the track in motorsports is how we improve the services that we provide to our customers at AWS.
Yeah, it's pretty amazing, isn't it, how you can push that cloud to the edge and then also ship the data. In addition to that, though, I realized I skipped over one of the great videos we have about how Riot Games is using edge processing as well, similar to what NASDAQ is doing. So let's go ahead and show you that, and then we'll jump back to the rugged edge.
At Riot Games, we build game servers in AWS and in our own Metal Colos. For the global launch of Riot's Valorant, our new team-based tactical shooter, we needed to rethink how we deployed our game servers worldwide to ensure competitive integrity. One of the most pervasive technical challenges in competitive shooters is Peeker's Advantage, which is caused by latency. Simply put, Peeker's Advantage rewards aggressive play because the defending player is always reacting on a delay. And for Riot, any problem that creates a lack of fairness is a problem worth solving. In the past, we worked with co-location partners to deploy our game servers in geographic locations not close to an AWS region to reduce latency for our players. With the demand signal during our closed beta, we recognized that our developers would need to spin up more capacity super fast, and for that, we wanted a better, more seamless hybrid solution. We shipped AWS Outposts to new colos quickly, enabling a rapid deployment of game servers standardized on a single build, test, and production pipeline. And best of all, using AWS Outposts, we reduced latency for players by 10 to 20 milliseconds, minimizing Peeker's Advantage and creating a level playing field for all players. With Outposts, AWS gave us a unique solution to ensure a level playing field for our players and streamlined our deployments using the same tools and APIs on premises and in the cloud. We rolled out Valorant fast and efficiently, and we are continuing to reinvent how we design and deploy our games to provide our players with the best possible game experience.
Yeah, it's pretty cool, and awfully important to a gamer like myself that that latency doesn't give my competitor an advantage there. But in addition to the outpost at the edge and the snowball at the edge, we also, of course, have these disconnected environments like disaster relief with Novetta, where they're able to bring their cloud applications right to the edge and operate them in disaster environments, which is incredibly life-critical, important operations on it. They run geospatial services on it and location services, along with a whole host of other life-critical systems that they run out there during disasters. And it lets them develop and test in the cloud and then deploy out onto the Snowball securely. And the Snowball can be shipped anywhere. So again, you get this common theme of pushing more and more processing to the edge, develop, test, simulate in the cloud, push to the edge, build your machine learning models in the cloud, push to the edge, kind of consistently across the platforms out there. And you see the advantages of edge processing and the cloud working together in gaming for massive scale, things like you see with Epic or what you see with Riot there at the edge processing. You see the advantages in connected cars, the ability to do more and more processing on the car securely, but also simulate the car as a digital twin, simulate the car in a simulation environment using the data you collect in the field to continue to enhance autonomous driving, the ability to install the Outpost and Snowballs in industrial settings. We have a number of customers who will have Snowballs and snow cones as hubs on the shop floor where it's dirty and dangerous and dull and all those good things where robots operate, and it's built for those kind of rugged environments. And then they'll have a local server room with a couple of outposts that are set up in an HA environment controlling their PLC, and all of that is connecting back into the cloud to do their denser processing back at the cloud data centers, where they have this advantage of high durability and to meet all their compliance requirements, keeping the data for long periods of time and things like that. And then this very exciting new hub and spoke architecture rolling out with 5G, the ability to push, like Riot and others are doing, to that 5G edge where there's super low latency out to their customers. Even robotic systems have that potential to have a certain amount of push to that edge, and we've been doing more and more experimentation with that, and the rugged edge where you're disconnected in a lot of different places. So it's exciting to see how all of this is evolving in healthcare, consumer, retail, oil and gas, government, smart cities, all those kinds of things coming together here. And the one advantage you get in working with AWS on this is we provide, again, this end-to-end seamless security and the ability to manage it. And we're continuing to integrate together our management tools with our IoT tools, with our geospatial tools, along with our 3D and simulation tools and our ML tools. So that all comes together. We have, products that extend from the cloud down to the edge. We have tens of thousands of partners that can help to deliver this for you. And we have, 2 decades of doing robotics, 2 decades of edge processing, 2 decades of cloud processing, just really out there. We've been in the cloud business for about 15 years now, we run, of course, one of the largest companies in the world on these platforms. So you can count when you're on AWS that we've had that experience running that scale and in security. So, this allows us to deliver to the edge when you want to deliver to the edge, and you can decide what you want to have at the edge. We've been doing it for a really long time, and we take what we learn there and build it into our products. We make it very simple to bridge your data from the edge to the cloud, and again, focus on that scale and reliability. So thank you all for coming. I hope you enjoyed the session, got a good understanding of how we're doing that consistent API end-to-end, and enjoyed some of the simulation and other presentations in robotics. Thank you very much.